and welcome back to my channel. I hope you guys have been doing well. So today we are going to solve some problems on limits. So let's begin with the first problem. So here we have given a function f of x, and we have to find the limit of the function when x approaches 0. So there are some values given, like when x is less than 0, the value of the function is x minus 2. When x is equal to 0, the value of the function is 0, and when x is greater than 0, the value is x plus 2. So let's see how the graph of this function looks like. So it looks something like this. So notice here that when x is greater than 0, like let's say x is 1, so the value of the function was given as x plus 2. So that is 1 plus 2, that will be 3, right? So it will be somewhere here. So here you can see this is the value of the function when x is equal to 1. So similarly, when x is equal to 2, we have the value of the function will be 4, so it will be somewhere here. But notice when x is 0, the value of the function drops immediately to 0. So here x is 0 and the value is also 0. So that's why this line, as you can see here, is not touching this axis, because when x is 0, the value of the function is 0. But when x is a little bit greater than 0, the value of the function starts from here, and then we have a straight line. Similarly, when x is less than 0, we have like minus 1, then we have x minus 2. So that means the value will be minus 3, right? So it will be on this line at this point. Similarly, when x is minus 2, it will be on the same line somewhere around here. So we have minus 4. So but when x is approaching 0 from, let's say, minus 1, it is very near to 0, but it is not equal to 0, then the value of the function, or expected value of the function, is minus 2. See, it's approaching minus 2, right? But it's not really there yet, and x is not touching 0. It is very near to 0 but not touching it, so expected value will be minus 2. Similarly, here the expected value is plus 2 when x is coming down, or is still greater than 0 but not equal to 0. So the expected value will be plus 2. So these are the left hand and the right hand limits. So here we can see when x is approaching 0 from the left hand side, the expected value of the function is minus 2. So this is the left hand limit, right? And this is the right hand limit. So when x is greater than 0, the expected value of the function is plus 2. So as you can see, these two are not equal, so left hand limit is not equal to right hand limit. So the question is, find the limit when x is approaching 0 f of x. So the limit actually does not exist at x equals 0. It is discontinuous. See, it is plus 2, right hand limit minus 2, so limit does not exist. For the limit to exist, we actually need left hand limit equals right hand limit. This is the condition that should be followed. So let's see another problem on limits. So we have been given a function f of x, where we have to find limit when x approaches 1. And these are some of the values. So when x is not equal to 1, the value of the function is x plus 2, and when x is equal to 1, the value is 0. So let's look at the graph of this function, how the graph should look like. So the graph will look something like this. So here it's a little bit complicated, not it's still easy to understand. So let's say when x is equal to 1, right? So the function was 0, the value of the function was given as 0. So that means that in the straight line there it's discontinuous. See, it is not continuous. This line is not continuous at x equals 1. There's a gap here, and we can clearly see that gap at x equals 1. So what's the value? So when x is equal to 1, this is the function of x, it's 0, right? But for other times, any other number except x is equal to 1, we have this line. So let's put some more numbers in. So let's see, when x equals 2, so what should be the value of I have actually written those numbers. So let's begin from -2. So when x equals -2, the value of the function is 0 again, and when x equals -1, it is +1. Here when -2 we have 0, and when x equals -1, the value of the function is here. So this is the point, this here again is a point, and we're connecting those dots here and making a line of the function. And when x equals 0, we have value of the function as 2. So here we have 2. When x equals 0, value is 2. So again we are connecting those dots, and we can see that it's a straight line actually. And then when x equals 1, we have 0. It's discontinuous here, right? So let me write this, continuous. So it's not, the line is not continuous there. But apart from that, when x equals 2, we have function equals 4. So that means it's a straight line. It will be somewhere here. So yeah, all in all, it's a straight line except for when x equals 1. So what will be the limit when x is approaching 1 from this side and this side, right? It's not touching 1, it's just approaching 1. So we can clearly understand that the limit will be somewhere here, right? It's not touching 1. So what will be the limit? So the limit will be when x is approaching 1 from the left hand side. That means we are not putting x equals 1, but it's approaching 1. So we can use this one is not equal to 1. We can use this function here. So that means 1 plus 2 is 3. So that means 3 is here, and it's the x is approaching 1. So similarly, the expected value of the function will be 3, either way, if I'm coming from this side or the right hand side. So when x is approaching 1 and is less than 1, so the expected value of the function will be 3. And when x is greater than 1 and is approaching 1, the expected value is still 3. So that means left hand and the right hand limit are same. So this is the left hand limit, this is the right hand limit, they both are same. So the limit exists for this function. And what is the limit? The limit is 3. This is the limit of this function. So thank you guys for watching, and please do subscribe. And if you want to learn about more topics, you can give your comments below, and I'll make videos on those topics as well. Thank you very much.